Hello, pre-calculus student. This video is for chapter 5.2, sine and cosine function using unit circle. We have seen from the last video that we define sine and cosine as the point of intersection of an angle, the terminal side of an angle intersects with the unit circle, and we can find the sine and cosine of all the corantal angle, meaning 90 degree, 180 degree, 270 degree. So now we want to find other angles, the point of intersection in the unit circle for 45, 30, and 60 degree. So they're all in quadrant 1. So I have them listed here. So what happened is I just move for the first one, I move a 45, 45, 90 triangle into the unit circle with the hypotenuse being 1. And because the hypotenuse is being 1, it coincides with the terminal side of a 45 degree with a triangle that is having a size of root 2 over 2, root 2 over 2. So that means you can clearly realize that the point of intersection is root 2 over 2 comma root 2 over 2 for a 45 degree angle. So that means cosine 45 is root 2 over 2, sine 45, which is y, is also root 2 over 2. So you get from this point, you can see this is the two number that we need to recognize. And then for the 30 degree, I'll move a 30 degree 30, 60 right triangle into the unit circle with the hypotenuse 1. And it would just cut the unit circle at horizontally with 3 divided by 2 and vertically 1/2 because for a 30, 60 triangle, when the hypotenuse is 1, the short side, which is facing the 30 degree side, is 1/2, and this is root 3 over 2. So your xy coordinate is root 3 over 2 comma 1/2 if your angle is 30 degree. Likewise, if the angle is 60 degree, then my 1/2 would be on the x-axis. My root 3 over 2 will be in the y-axis. My point is 1/2 comma root 3 over 2. So all of a sudden, we have a lot of sine and cosine that we can read off for this special angle, and they are exact angles. So they are not approximate 0.1, 2, 3, 4 something. The exact value, and they are special angles. And if we do the same thing for the second quadrant, namely, I'm going to put a 30, 60. So if this is 30 degree, right? So this is the reference angle. The actual angle should be 150 or 5 pi over 6. I will have this point of negative root 3 over 2 because this triangle is actually having 1/2 here. If this is 1, so this is a unit circle is 1/2, and then root 3 over 2, but negative. So you can see that the point is negative root 3 over 2 comma 1/2. And use the same argument, I can put a 45 degree, I can put a 60 degree angle here. I would have all this field. Okay, so in the first quadrant, we have from 30 degree, which is also pi over 6, with these two angles, which is cosine and sine of 45, cosine and sine of 60, and this would be cosine and sine of 150 or 5 pi over 6, cosine and sine of 3 pi over 4, cosine and sine of 2 pi over 3. So all these are being filled using the special triangle, and this is the unit circle. Okay, so meaning if I am, and even the 270 degree and 3 pi over 2, we will have it also over here. So if someone say, okay, so here, I'm going to erase this because this is just an illustration of this particular one, how we generate this. We do the same thing to generate quadrant 3 and quadrant 4. So if I am to ask you to find sine 330 degree, all you need to do is look at, I know 330 degree is the result of having a 30-60 triangle here. And I have recorded root 3 over 2 comma negative 1/2 in the unit circle. So my sine 30, so I usually would just get myself familiarized with the unit circle, which just say, I'm going to draw the picture. I know 330 is here because it go all the way here. And this point is what? Um, x is root 3 over 2. Y is negative 1/2, right? I actually write it down, copy it from the unit circle, right? See, root 3 over 2 comma negative 1/2 is negative. Why? Because y in quadrant 3, quadrant 4, y is negative. So then I want sine. Sine is the y value. The y value is this one. So this is negative 1/2. It's that simple. So after a while, you can skip drawing this and just say that look at the unit circle and then find negative 1/2. Let's practice another one. Cosine 5 pi over 6. Where is 5 pi over 6? 5 pi. Oh, over here. So in class, I'll teach you how to recognize these numbers. I think in the last lesson, we talk about how to recognize the special angle, but 5 pi over 6 is here, is negative root 3 over 2, 1/2. So to get myself more familiarized with this, I would write, okay, because the more you write it, the better. You will say 5 pi over 6 is here, and this is 5 pi over 6. This angle is 5 pi over 6. The angle is negative x, right? Negative root 3 over 2 and comma 1/2. I want x value. X value is negative root 3 over 2 because the x value of 5 pi over 6 is negative root 3 over 2. Do you see? Now about cosine 4 pi over 3. So I look at unit circle. It should be in quadrant 3, right? Oh, no, 4 pi over 3. 4 pi over 3. Yeah, quadrant 3. You see 4 pi over 3? And I have negative 1/2, negative root 3 over 2. So I'm going to remind myself, draw the unit circle, that this is 4 pi over 3. And the point is negative 1/2, negative root 3 over 2. But this person wants cosine, so it's negative 1/2. X is cosine. 7 pi over 6. Where's 7 pi over 6? It's right here. Negative root 3 over 2, negative 1/2. Okay. Input 7 pi over 6 right here. And this point is negative root 3 over 2, negative 1/2. I want y value, sine. Sine is y value, negative 1/2. This is the y value. Sine 7 pi over 6, right? Root 3 over 2, negative root 3 over 2, negative 1/2. Why is it root 3 over 2? Because we jam a 30-60 triangle here. So this is root 3 over 2 and this is 1/2. But they're both negative coordinates, so we have both negative. Okay, so this is how you read off angles that is within 0 to 2 pi or 0 to 360 degree. They shows up in the unit circle. All these angles shows up is between 0 to 360, right? What about if I ask you, I want negative 120 or I want 450? So they are not in the unit circle or negative angle, right? You can do backward rotation, but I just want to use the unit circle to do it. So how do I do? So this extra step you need to do is find the coterminal angles of this input. So first step is to find the coterminal of angle until it is between 0 to 360 or 0 to 2 pi. Then use the xy intercept for sine x and sine y because coterminal, they have the same terminal side. So I can use the same xy for sine and cosine. So let's look at negative 5 pi over 6. What is the coterminal of negative 5 pi over 6? Well, it's a negative angle. I'm going to add 2 pi coterm. We know of negative 5 pi over 6 is negative 5 pi over 6 plus 2 pi. That is 12 pi over 6, 7 pi over 6. So my goal now is to look at 7 pi over 6. We did it here. is negative root 3 over 2, negative 1/2. So I'm going to write it down. So in the unit circle, negative root 3 over 2, negative 1/2. I want sine. Sine is negative 1/2. Y value. Right. Sine negative 120. So coterm of 120. Oh, negative 120 is negative 120 plus 360 equal to 240, right? So I'll look up the unit circle at 240. I think it's here. Negative 1/2, negative root 3 over 2. So the point is negative 1/2, negative root 3 over 2. Do they need cosine and sine? They need sine, which is y, which is negative root 3 over 2. That's the output. If my input is 450, what is the coterm? Coterminal of 450 is equal to 450 minus 360. That's 90 degree, right? So look at 90 degree. What's the point? The point is 0, 1. In the unit circle, so yeah, you don't need to do calculation. You just look it up. 0, 1. I want cosine. Cosine is x, right? X. So that is equal to 0. Cosine 11 pi over 4. Do I have 11 pi over 4 in the unit circle? I don't think so, right? So the highest is 7 pi over 4. So this must be outside of the 2 pi. So I would do coterminal of 11 pi over 4. That is 11 pi over 4 minus 2 pi, which is 8 pi over 4. That is equal to 3 pi over 4. But I know 3 pi over 4 is right here. So you see this 3 pi over 4 is negative root 2 over 2 and root 2 over 2. So the point is negative root 2 over 2 and root 2 over 2. So cosine, sine, that what do they want? They want cosine. So cosine 11 pi over 4 equal to negative root 2 over 2. So you can see that you always just use the unit circle. This is another method to find sine and cosine using reference angle method. So some teacher, or maybe later on your physics teacher or your other math teacher would use reference angle to find. So the method would be they would not be using the unit circle. So this is later on if you don't have the unit circle, you lost your unit circle, you can still figure it out. So what you do is you have to sketch the angle in standard position, find the reference angle by and then put a triangle in it, put a special triangle. So you have to remember the special triangle of 1, 1. Oh no, 1 root 2 over 2, root 2 over 2. And this one, that is 1/2, root 3 over 2, when it is 30, 60, right? So just 1. Okay, so let's do 315. 315 should be all the way here, right? 315 degree. But if I am to draw a triangle of a unit circle, what would that be? It would be this one that I draw. I use a reference angle of 45 degree. 45 degree is 1, 1 root 2. So this would be a negative root 2 over 2. Horizontal is a positive root 2 over 2. So cosine is the y coordinate, so it's negative root 2 over 2. You see how you use the reference angle 45 degree. Okay. So negative pi over 6, oh, we don't have to, we would just draw it, right? Negative pi over 6 is like here. Let's put so pi over 6 is, that's 30 degree, equal to 30 degree. So I'm going to put jam a 30 degree triangle here because this is 30 degree, right? So for 30 degrees, so this is 1/2 and this is negative 1/2 because it's negative. This is positive root 3 over 2. So our cosine is positive. So the point that you get is root 3 over 2 comma negative 1/2. I want cosine, which is this one, is root 3 over 2. Okay, so basically you draw this triangle, this one of these triangles. This triangle is easier to remember than the whole unit circle. Okay, you draw it and then you make a picture, jam a right triangle into it. Now those triangle has to be either this way or this way, right? Or this way or this way. Has to have a side on the x-axis. And these are the reference angles. So this is called a reference angle method. You don't have to use it if you're comfortable with using the unit circle method. Then, oh, okay, I'm gonna finish. What about if it is the angle is not a special angle and it's not a corantal angle, but I want to find sine and cosine. So what you do is you use the calculator. So be aware that angles has degree or radian. So when you do this, you have to make sure that you are in radian mode if it is a radian input. And if it is in degree mode, you have to do a degree. So I'm going to show you with here. Instead of the decimal graphing calculator, I'll use a normal graph calculator. So in a scientific or normal calculator, you typically would have this, and then you have to say mole. Okay, turn on first, clear all this, and then mole. So by default, it's in radian mode, so it's radian. So you can input your stuff in radian. So if I want cosine, what was the one that I want to do? 5 pi over 12, I would do 5. Pi is second up arrow over 12. That's what you enter it. So this is in radian and it's 0.2588. So usually for decimal place. Sine pi over 5. So I would press the sine. Oh, is it pi over 5? Oh, pi over 5. Second pi, and then divided by 5. 0.5878. This is, oh, 0.5878. Okay, so that's how you do. Oh, two decimal place. If it's two decimal place, then it's 0.26, and this will be 0.59. Okay. What about if I say cosine the 415 degree? Now, the good thing about a unit circle is even though this is greater than 360, you don't have to do coterminal angle. So you can just switch it to, but you have to switch it to radian. Okay, press degree, and then what do I want to do? Cosine 415. Cosine again, and then 415. You don't have to say degree because it's in degree mode. They know it is 0.573, 0.57, okay, to 0.57. So tell yourself it has to be in degree mode. By default, if we are using this as a periodic function, the input are in radian mode. Okay, so that's all for chapter 5.3.